Cool, Brit. I'm excited to talk to you because you're a very mysterious figure to me. Let me illustrate the scene. I'm on Khan Academy. I don't even remember why, checking out the computer science material. And a lot of it is, what I would have expected, like approachable, uh, clean, homogeneous,
Mhm.
easy CS material. And then all of a sudden, there are artistic, challenging, probing uh, questions, challenges, as well as expository material on information theory and cryptography and topics that are seen as maybe too. Would you say it as almost too interesting? Considered too interesting
Yeah.
for like middle school or high school computer science
Yeah.
education.
Nothing
And
to see here. Go back to your room.
it's like, no, get back to the like Java object oriented programming for 15-year-olds.
Or is
uh
this going to be on the test?
is this going to be on the test? um yeah, so that's how I encountered your work, but obviously you've done a lot of really interesting computer science education work, and I mean more broadly as well. And so I'm excited to talk to you about your journey of bringing this kind of uh, this perspective and this kind of culture to computer science education. Um, Maybe I should leave it to you to try and describe that.
Awesome. Yeah, I'm happy to be here. Nice to meet you too, Charlie. First time we've all chat. Um, because you're an educator too, I'll just jump right in there, which is, yeah, what is that doing on Khan Academy is really funny to reflect on because it's been a while. I think that was more than 10 years ago. And so the short story is that nothing really is ever new, right? And so when I was little, the educational content that inspired me mostly was James Burke's connections type stuff. Same thing.
Fantastic.
You're flipping through the TV and you're like, what's this? So
Absolutely.
different. Long, deep narratives. Why is everything so interesting? Right? Like it's like Bill Nye, even like that sort of stuff, the more traditional, interesting stuff like whiz bang gravity, that was really the standard. And then you see something like connections and you're like, what is going on here?
Can I was not aware of that. Can you just give me an overview of what connections was? I was more of a Bill
Oh
Nye.
my God, Charlie, you're like your next 3 days are James Burke's connections.
Okay.
Yeah, it's like saying, oh, I ain't heard of the Beatles. What was it?
Oh God.
But no, it's a good question, but it's not well known. So it's really a British show, and it has one or two other equals. Carl Sagan follows in the same footsteps if you've seen Cosmos.
Yep.
But the cool hook about what he did is I maybe mentioned two things. One is the structure of the show, and one is just how it was produced. So the intellectual structure of the show was not just telling a story about history, but he told a story of a series of events that connect. And these events were usually inventions and how those inventions shape the world. So he'll go from like the invention of something very mundane, like stairs. I'm making this up. And that'll lead to like coffee 10,000 years later, and then somehow satellites.
Yeah.
And so he just told the story in a very different conceptual way. But then he also did it in a way that was had like high quality cinematography and very visual, which was why it stood out. And
If you search on YouTube, I don't know for sure, but I believe if you search on YouTube for best TV sequence ever, you will find a James Burke scene that ends in, well, I won't ruin the ending for you.
Yeah.
But it's
No
just
spoilers.
like the cinematography is fantastic, but it is about like the history of invention, and he brings this unique perspective to it of the interconnectedness of these things that other historians don't look at because of just an alternative perspective that they take, maybe due to like the more academic approach of focusing on one area or another. Like for computing, for instance, he starts with bells. He starts with monks ringing bells. And he's like, well, if they're trying to automate the bell ringing, maybe they've got this flowing water. Maybe they can utilize it with this system that has these like big metal things that move levers and that rings the bells in a kind of predictable way. And maybe that's the inspiration for, am I going to ruin the ending here? Maybe that's the inspiration for automating looms, although he goes through like the step-by-step, like how we got to the jacquard loom, not just the punch card aspect of it, but the like other pieces of that invention. And then you're like, well, like 5-10 minutes later, you're in the tabulating machines where the punch cards now are for the census, but that's all in the like the historical context of why the census, the US Census, started to become hard to compute, like in the immigration wave and so on, motivation for the tabulating machines, how they came from the jacquard loom punch cards. Like it's all, you get like a real sense of why people invented these things in the connection of the problems that they had, but also the inventions that were in other places, the social connections. Like, why did we even need to automate the jacquard loom? Like, why was it that everyone wanted to wear silk? And now I'm gonna just relay the whole. This is gonna be like a James.
It's like retelling a joke.
Yeah, but the series 1 came out in 78, and then there was a gap until 94 and then 97. So
yeah, that was exciting when that came out in 94 for us in the 80s growing up. Actually, I born in 84, so I was like right ready for number 2. But again, because you haven't seen it, and it's fun to switch up back and forth, is I was so into that show that I know everything about how it was made, and there's a part of it I don't like, and it's a bit of a trick. And even while you were recounting it, it hit me. And so let's go back to, how did he make his show? He would go back, he would go to the library, and he would find any invention. I'll just grab, a sock. And then I'll say, I'm going to start at a sock. I don't know where the story's going. And then he would go to like, well, let's go back to the origin of a sock. And then he would look at everything else that happened in society at that time. And there's a million ways right there the story could change. Oh, it turned out in that era, so-and-so needed to go so-and-so, and they invented this sort of ring hook mechanism. And then they'll take that mechanism, goodbye socks. Let's go follow this now to the next historical event, then go there and look at everything else that happened. And so it's kind of a choose your own adventure when he was doing his research, and you could rewrite those in any way. It wasn't actually a fundamental narrative through. It was, wow, these things led to a lot of unexpected things, and we usually get to the shuttle or the nuclear bomb or whatever. And so
this is like me reading Wikipedia.
Yeah.
Yeah.
Right. It's reading Wikipedia. Yeah. And so it's fun when you go back and you only really, a few memories stick with you. And one memory I remember explaining to my, so now I'm in university and I'm studying computer science, and the same thing there where you're like in the driest classes ever. And then somewhere during the middle of a really long lecture, someone says something that you're like, what did he just say? That's what computer science is about? What's a push down automata? What? We can do everything on the chalkboard. And it would be like, it would blow your mind for a second, but then you'd be drowning in so much work. Same with cryptography. And you're like, whoa, there's like, I can't tell the difference between a coin flip and someone just guessing. And then you move on to some algorithm and these little glimmers. And I had this sense that, man, this is so hard and annoying. And not, like you said, not only does no one learn it earlier in school, there's like some really beautiful ideas here that you could explain in very simple terms, but they're just shrouded in these weird mysteries and complexities. And I remember thinking, wait, what if you just go back to what James did with connections and do one small tweak, which is, instead of following inventions through time, I'm going to follow the concept through time. And that'll allow me to hold on to something as I jump through time. And then there's going to be a lot of ways that concept, and that's why you bake it in a problem, a lot of ways people try to solve it or think about that concept, but you're still in the same context. So I chose, like with cryptography, obviously, keeping a secret persists through time. And when I'm doing my research, I kind of get to do the same thing where I'm like, what did everyone do back then? Oh, I'm going to take that cool example. And by doing that, though, I led to my kind of one takeaway, which was I wanted to teach forwards, not backwards. And the other thing I hated in school is you'd be learning an interesting, complex concept, how they're implementing it today, and they'd hint back to like, hey, I'll just stay in cryptography for that context. Oh, Caesar, back in Roman era, they did this. And then you jump right back and you're like, what? what just happened? Wait, they were doing this 2,000 years ago, and it was way simpler and fun to understand. Why didn't I learn that first? Then this, then this, then this. It seemed so obvious to me. I'm just going to teach forwards in whatever I was going to make. Then it's both fun, like connections, but I actually do walk away with a deeper insight. And that's what I wanted to do, is take, like, after leaving computer science, I remember thinking, man, there's some stuff that took like years that I could have learned in like 4 hours.
What's the like shining example for you of something that took years that you could learn in 4 hours?
Oh, well, there's so many things. So let's just jump to a different example to keep it interesting, which is like Bitcoin and blockchain. And I'm like so tired of, I've spent so much time on it. I almost don't even like talking about it, even though I'm still a big fan and I love the technology. But let's, like, a key insight behind the blockchain is there's so many ways to go about it, but you won't know what I'm about to say. Your next word prediction probably won't say this. But it's the honest chain grows the fastest, this sort of stuff. I don't know if you have a background in blockchain, but like, the honest chain grows the fastest. We can go into like, what's a chain? Why is it growing? Blah, blah, blah. But like, oh, I see it. Stuff like that. I mean, that's the mechanism of Bitcoin. And then in terms of like the economic, political insights of Bitcoin, is rarity has value. I don't care how the rarity manifests. It happens to manifest on a shared ledger. The ledger is secured because the longest chain grows, the honest chain grows the fastest. So there, I spent so long, I think everyone did. And that's why Bitcoin was exciting, because it was new, and it's very much like deep learning, where it's like this black magic, and like you have to go off the deep end to understand it because there's no textbook, etc. So that was a really fun one.
I'm just trying to follow the example. Is the idea that there's a first principle or like fundamental truth that just took too long to discover? Is that what you're trying to say?
Maybe that's a good way to put it. It's kind of, maybe it's like the attractor pattern behind all these different explanations in a way. Another one I loved was information theory. And this was like, rarely, I'm not an expert, and I don't think I ever had an original idea, to be honest. Like, my original idea is, how compressed can you get? And that has occasionally led, I think, to a new idea in a few cases. And there's only one I'm sure about, which is an information theory, when I needed a physical analogy for everything I taught. If you don't have the physical analogy, you don't understand it.
Yeah.
And entropy is a fun one. And so the one that I had and is new is that, what does it mean that something has a certain amount of information? Well, and we measure that in bits. Well, what is something? Something's the next word I'm about to say. So there's a set of words I might say, and there's some like expectation or a way to measure how uncertain you are about what I'm about to say. All that sounds so confusing. It's like, what the hell are you talking about? Well, and here's the physical, let's just stay in a physical analogy. I'm about to say a word. Let's just say there's 1,000 words, there's more, but 1,000 potential words I'm about to say. We can be very specific about how we're going to measure that by imagining it as like a binary Plinko machine, where at the bottom of this machine is all the possible things I'll say. And at the top, we're going to drop a puck. And that puck can only do one thing. It can bounce off posts. And it's, how many posts do you need? I'm only going to give you how many posts do you need, or how many layers do you need? Because, sorry, I remember in the video, I got this simplified down to how many bounces do you need? How many times you have to bounce something to guess what I'm about to say? And each bounce is a bit. And if you measure the height of the tree, it's the log, and it gets you to the entropy equation. You're just measuring the height of that machine. I remember telling someone that, and they're like, oh, shoot, you should publish that. And I went like down that road, and I never finished that road because I'm not an academic. But that's one I love.
I try and start my kids early on that with 20 questions. I'm like, no, that's not a good binary search of the space.
Exactly.
My kids are 2 and 4, so they're not
asking the right questions, probably.
Oh, that's fine.
So you're saying a coin flip is a coin flip just one bounce? Is that what you're saying? Okay.
One bounce, 2 buckets.
Yeah.
And so compression is finding the minimal machine that'll do that. And ever since thing, I'm still on a pathway of like, there's so much unification that happens around information theory, which still is a weird black magic no one in the real world ever talks about or hears about to this day. I remember telling Sal Khan, I was going to do information theory, and he was like, ooh, information theory. Like, oh, have fun. It's like,
Tell us
go have
about
fun,
that.
do whatever you want.
You speaking of Sal Khan, you were at Codecademy quite early, I understand, like the first year or so. What was the mood, the culture of Codecademy like at that point?
Yeah, that oh, and so to complete that path, that when I started thinking I was finishing school and wanted to explain things better, just a few months into working as a developer, which I didn't like, I was in Montreal, I went off and just made some little videos, like just to get a sense of what this thing would be, because I wanted to do a TV series, and went through that whole thing of like talking to someone about how to do a TV series, which was like, the way to do it is to already have a series, and maybe you'll have some luck on the internet, she said to me. So I posted a few videos. Sal saw one of those, and that was right in his first year, where naturally he was going online to see who else was doing stuff on YouTube, By Heart, etc. Invited all these people down. So that's how it happened, totally through YouTube, which I always like that story. And of course, I'll never forget when I flew down for this was the first team meeting, might have been at the Computer History Museum or somewhere around there. And I still have a photo, it was like maybe 25 people. And it was like a total whack pack of different, really smart people, like popcorn with like no clear path of where this was going. But it reminded me of when I was in school one year in the gifted program, where they just put all different kids from different schools in this one room that they didn't know what to do with. It was like that times 10, just with slightly older people. So I'll never forget just an incredible buzz and energy. And I think everyone might have this happen a few times in their life, or they're lucky enough to live in it, though you get acclimatized. But when you're put in a room with like, I don't know, certain groups of people, something happens, especially if they have a shared kind of interest. So there was like a resonance and just an excitement that I remember. I was like bitten by a bug, and I still remember it. So that was the initial thing, just energy and endless optimism, and so many different smart people with different skills. No like group that was the same. Everyone was totally different, working on different problems.
Is this the sort of I think a lot of startups try to have this sort of like mission-oriented culture, which is sometimes like the mission is not that inspiring and you're maybe just trying to underpay us or something. But I do feel like if the mission is real and you have this diverse cast that comes in, it can be magical. I worked for an ed tech company in New York that was trying to do adaptive learning. It was the same sort of thing. The misfit crew that we assembled of people who were like, just pulled off of Craigslist that were teaching like LSAT prep and SAT prep, and you kind of throw them together. I still look back on that. Every company I've worked for since, I was like, why does it not feel like this environment? Can I ever will I ever be able to go back to that environment? And we made some amazing stuff. Not nearly the impact of Codecademy, but it still is probably the high point of my like professional career to this day. And I miss it all the time.
You remind me of two things. One is the whole, that Codecademy's mission was so awesome, simple, but almost like all of them so broad that you could get yourself into trouble on what do you practically do tomorrow. That whole thread. And the other one is that as it kind of started, it was not quite baked in from the start, but basically from the start was this like, Sal's making videos, but the real idea was this adaptive software mechanism that's going to adapt to you. And what's so fun, that's just a different thread. I don't know where you want to go, but I just remember being totally against that at the time. And then look where we are today.
Where are we today though, right? Like I actually haven't been able to try out their LLM based tutor thing, because it's not, I mean, it's like in beta in the US or something. Have you tried it?
So what no, I haven't, but I was referring to the collective, not specifically Codecademy, where it's like, I'm telling you, I'm going to make a tutor, like you're going to say, okay, I'll I'll build a GPT actual tutor now. I thought I have access to it in 2 minutes and it's done, and I can do it myself, and I don't need 100 million in funding. It actually exists in the form when he was pitching it at the time. It just did not seem likely at all. I'm working on the video I've been working on now. I've been over a year is on LLMs, and what the heck just happened? Because even when I started the AI series 2 years ago, things have changed so much. It gets us a bit off Codecademy, but yeah. So I haven't used it, and actually, I did speak with Sal like months ago, and I was like, I just said, I can't believe what you're doing this. Let me know if you want any help, and we had a back and forth. But they're building a layer around GPT. Even just when they started that, it was like, it seemed like they had a head start because they're working with OpenAI AI to do that fine tuning. But not even like a year later, anyone can do that. It doesn't require any sort of special access, which is interesting.
I'm curious, Brit, when you went down there and Sal sort of gave the pitch and the vision, you were kind of off doing your own thing. You had Art of the Problem, I believe was the name of the series. Was his pitch just continue doing what you're doing, but do it within our umbrella? Or did you kind of did you redirect your interest towards this broader thing? How much freedom were you given? Did you move down here? Because I feel like if I looked at your career, my take is that you've done a good job of saying, I don't want to do this. And I just want to I have this creative pursuits. And maybe now I'm understanding it's all stemming from the television show, the James Burke show, and trying to recreate that in your own way. But I'm curious how much you were able to take that with you and drive what you were building. And it seems like that's continued beyond, but what was Sal's pitch in terms of you coming?
So you're right. His pitch was amazing. It was, will you keep making those videos for us? How much will it cost? And I made my first mistake when I was like stressed out of school or whatever. And I'm like, first he thought there was a team making it, and it was no team. Yeah. There was me and whoever I would bug to read a script. And so I was just like, I'll do it for anything, basically.
Do it for free.
Yes, I did fly down. I would have done it for free.
Yeah.
And so it was just come do whatever you want. And so that was at the time, Sal, again, brand new, big potential, fresh startup with money, able to just say that to people, like, come just into our orbit, we'll figure it out later, which is funny. And so, yes, that sounds great. And yes, I very much was I'm going to keep doing what I'm doing. That's what he told me to do. I'm not going to come and try to solve this educate the world problem. I'll just stay in my lane, which I have always done, but I don't think of it as a virtue, because I mean, going back 10 years to today, I have so much more bias towards what I could do with others than what I'll do on my own. But that's what I did for the first few years. I was able to just stay in my lane and say, I'm going to make these episodes that I had all in a notebook from years back. I had sketched out what I wanted to make, and I was just kind of cranking through it. In the second half of the years at Codecademy, did a lot more. I got itchy and just started experimenting like crazy, just doing anything and everything I could try, which was, again, part of that freedom and chaos, which is exciting.
So speaking of information theory, what's the compressed, you went through the multi-year process of learning. What's the output for us?
It's that Plinko analogy, or is that what you're asking?
No. I mean, your experiments around learning.
Oh,
yeah. What is
like in the second half at Codecademy?
Yeah.
Oh, yeah. I won't enumerate them all, but I'll just say that, like, I tried both the physical stuff, like we did our camp and design. I remember like me and two others, we designed the camp and ran it, and tried to do teacher conferences and a lot of physical things. And in terms of virtual, that one thing that hit me was this issue of videos are so hard to modify, especially back then. And there was this big queue of changes that needed to be made on videos. And so I was always pushing, like, I don't even know if we need, like, I don't know if I like videos anymore. Videos take long, you can't iterate. Let's just do text and interactive elements. Pushed really hard for interactive elements and text and what we could do. And imagine we had those pages and we could just keep modifying it and ever improving it. You don't feel as handcuffed as a video. Pushed really hard down that avenue. And I'll just stay on that one because it resulted in a happy accident where I did do, I wanted to do fully text-based adventure kind of, or text-based lessons. And then one of the things that was not being properly utilized at Codecademy was the community. And you could kind of see this when the CS platform started, but even before, where there were people obsessed, they living on there, all down in the comments, which is just on the periphery fundamental of the learning experience. And so my first little dipping the toe in the water, I didn't even know what I was doing. I'm like, I'm just going to start a lesson and ask the community where it goes. That was, and then I remember the response was really active. And so I pushed that with this cryptography adventure, which is still on there and it's still awesome. And it's like a little story where at each step in the story, there's like a challenge and I throw it to the community to help each other solve that challenge. So it's like a communal learning experience, which that's probably the one thing out of all these different experiments that there is a most potential. And I actually continue to this day is, what's the role of the community in the learning experience? It's always an afterthought. It's always like, I'm going to tell you all this stuff. And it's not about always what your involvement in the cycle will be. And so when years later, I zeroed in on, and this gets to what I'm working on. One of the things I'm working on today, which is experiential, which is a learning platform that starts with what will the users do and how will it get better with more users and how much peer-to-peer learning can we support? Peer-to-peer learning used to be an accident. And what if we put it at the center and started blowing it up? And when you come down to it, if you do peer-to-peer learning right, the role of like the expert gets really small and gets kind of pushed to the edges like before. And so that led to a different way of thinking about, and it's so obvious now that online, yeah, it started with putting PDFs online, then it started with videos and interactive elements, and then these little things you could click through with tests. All that seems so kind of old-fashioned to me now that I'm in this. Well, online means a collective of people, and if you got to be maximizing the use of that collective. And so the new way that I actually measure, like, if a course is successful, is actually the words exchanged per user. Totally different kind of North Star. That was a kind of a bit of a diatribe, but that's where I kind of saw the most fruit.
So it seems
that's
like
exactly sorry, John.
No, I was just going to ask Oz. I when I'm thinking about the Codecademy example, if I went to that today, what I'd fear setting something like that up is the top voted comment maybe is something funny, hopefully, but it also just could be the answer. Whereas probably now you have folks going through in a cohort. So the answer hasn't been published online in some Reddit forum or something like that. Was that a problem? And does the sort of community in a cohort experience matter, or am I misthinking about this?
It wasn't a problem. And if you set the culture right, I don't know how to explain it, but instead of what you'd think, which is, oh, if you call to the community to solve a problem together, someone's going to immediately ruin it for everyone. It was the opposite of that. It was everyone followed the rules. I don't know. And people were just there to help and wouldn't want to give away the hints. I'm speaking back in the Codecademy experiment days. It just didn't happen, which is why it was an experiment. If that happened, like you said, it probably would have died and I wouldn't have thought about it after that. Like, oh, of course that won't work.
Yeah.
People do want to have fun. Yeah, I mean, I was going to reflect on that in the context of CS Primer as well, where, by the way, thank you, Brit, because like, as you say this, I'm like, no, I'm not doing the community stuff enough. Like it is like a thing that I'm leaving too much as an afterthought. We've got a Discord server, but I'm not thinking about like, how do I encourage certain dynamics on that server? But the community is good at things like putting spoiler tags on. So there are like cultural things that like are just a default that are quite nice, of like people being respectful of one another, realizing that everyone's on a different part of their journey. And I was glad to see that kind of thing. But in terms of like active encouragement, like I think that one of the best things that a learner can do is, I mean, this is a kind of, it's repeated so often that it's almost boring to say, but to help others, not just as a forcing function to distill their own knowledge, but to start to interrogate like the fundamentals of what they have. Like how would I ask questions to help somebody else get to the next level? If I'm giving a code review, what do I focus on? What is the like essential aspect of this this piece of code? So I'd like to encourage that more.
Yeah, we could actually geek out quickly on that, on this course design. So let me just fill in one thing, which is, so when I left Codecademy, I had met two people who worked at Pixar. We made Pixar in a box when I was at Codecademy, which is very much like a video series of how they make their films. And the most interesting, hardest part was the storytelling curriculum, because it was in our third year of working together where we had finished that flip of like, what's going to work best is what are the users going to make to learn story, not us telling stories about how stories are made, like how you might teach how they, again, what we covered, like the computer science aspect of what we did. It was that model of, we're coming to tell you how we do things and we'll give you a little tool to play with. But it was very much what we're going to tell you. Stories about what you're going to do. So it was kind of scarier as a curriculum design, but we did it and it worked well. And then years later, when we actually, this is Tony and Elise, we joined up and started a company. We went back to, well, let's do what we did with Pixar in a box, but actually take it to the next level. And so instead of just learning about storytelling, I remember thinking like, I want to put someone in the driver's seat, like they're working there, and go through the process that the pros actually go through, as if your parents were working there and you're just sitting in the office, like making your story, going through all the departments and actually walking the walk. And so to pull that off like before we built the platform, when I looked at what was out there, is all these, again, expensive storytelling courses. And we were all about trying to reach people low cost. So there's no point. Why are they expensive? Because you have these master storytellers giving their precious time to a small cohort of 30 to 50 people. I'm giving this background because I don't know. I want to pressure test how this applies to other contexts. So in story, what I think the key insight was, an expert really does two things in a cohort course. They're delivering content and answering questions and that sort of stuff, which can happen in a many-to-many. But the one-to-one, I'm going to give you notes or feedback or help, that's the expensive waste. And what if we cut that part out and replace it with the peer-to-peer community? If you do that, you could scale infinitely with no extra cost. And why might that work? Well, we know it'll work in storytelling because storytelling is it's human nature, and any human can tell you if a story is working more or less. So if I want to get advice on a story, I could ask an expert, or I could ask 6 people. And the conceit was, you know what? The 6 people aren't experts, but in aggregate, if they have the right mental model and they're in this together, just like we've seen, they'll probably do as good, maybe better. I don't know, but if would that work? And so how are you going to evenly distribute all this peer-to-peer? It seems like chaos. How would it work? And the second insight was really simple, which was, well, let's imagine in this story course has 8 steps, so 8 deliverables to get you to your final story. What if at each deliverable, you upload to a system that pools everyone's work into what I call the gallery. And when everyone does the course, when you upload, before you get into the gallery to see all the work, a wall pops up and makes you give feedback on 3 or 4 random other projects. That if it's 4, that ensures, and everyone's going through it, that ensures every time every person's going to get 4 pieces of feedback. Nobody gets ignored, which I love, because on YouTube, there's this long tail of being ignored. And so with this system, imagine you fill it up with people, everyone gives each other notes, nobody's ignored. It might even be better. And so that's what we built with this story experience. We built the experiential platform, put the storytelling curriculum and uploads in it, built those galleries. And this was in basically right at the end of 2021, 2022, when we put the first 2,000 people through. And it went very well in the sense that the completion rate was 90%. Which we usually would be 9%. And this big shift was the evidence for me to be oh, this is the way to go. nobody was saying, oh, I didn't get feedback from so and so, because we put the top experts in, but they were just broadcasting on interactive live streams, never giving notes. And the community filled in that gap, and the marginal cost per user is very, very small, vanishing basically.
But
And
I
so
want to
that's a
say,
long,
firstly,
sorry, I just want to say, so that's in story. Will this apply in other contexts, and how?
firstly, everyone should check out. I'm pretty. You can still access Pixar Storybox on the Khan Academy website.
Pixar in a Box, yeah, is on
Pixar in a
Khan
Box.
Academy,
Yeah. Great work. Like, I think definitely in agreement with you on this aspect. Like, firstly, what is it that the learner is going to actually do as part of this? Not like, what is the information, like what is the scope of the curriculum or whatever. I think that's like one of the biggest flaws. And like, to be frank, the core of Khan Academy is like, how do we cover the curriculum, right? Like that's the originating kind of culture of that. Like that's again why encountering your work on Khan Academy was a kind of shock. But so, you know, I'm saying that as a compliment. I think I agree with you on this track. I was curious how familiar you are with the coding bootcamp scene, of like the hack reactors and dev boot camps and the kind of like that industry, how that industry established. Have you been exposed to this much?
A little bit, and I do pay attention. I try to pay attention to it.
So like to clarify, I was never part of this industry, but a lot of my students were boot camp graduates, including Charlie, and so I've come to understand like what were the key decisions that those dominant boot camps tended to make. And it's very interesting to consider what they did in terms of peer-to-peer learning and trying to like get some scale, and like what that was successful at. And maybe I focus a lot on what that was not successful at. But do you want to talk about that a little bit? Would that be interesting to dig into?
Yeah, sure. I'm curious what comes to mind as what was not successful.
Well, yeah, I want to hear what Charlie thinks as well, because he was.
Well,
he was
I'm also thinking one issue sometimes with that is that distinction between peer and the actual teacher is almost not there, because very often the previous cohort just becomes the teacher of the next thing. But going through that, I do feel I'm a happy boot camp grad. I was a history major. I was working in finance, working in sales for this education company. I went into this being like eyes open. I heard feedback that, you know, what you put into it, you get out of it. I have that mindset that I think a lot of people do. Man, if I could only go back to college again, I would really actually read my textbooks. And this time I would really do it. And I tried to take that approach for the coding bootcamp. And I look back on it fondly. I mean, I think it was a bunch of people who raised their hands and said, I wanted to do this together. We were in it together. Some people had more experience than others. And if you were smart, you learned how to navigate that. And I learned a ton from people who knew way more than I did. And I also tried to set my expectations like, okay, I did not figure out how to do n queens using bitmaps or something like that. And I was like, man, maybe I'm never going to make it, but you have to like move on. And I allowed myself to move on. But doing that 3 months course, we spent a day on databases, literally a day. And that's when I found like, that's clearly not enough, but they were trying to gear you towards, let me give you like a survey of the landscape, make some practical projects, which is probably the best thing we did. By the end of it, you have a couple websites, maybe an app that you can show to an employer. And then they also did this sort of, every day we did a toy problem, which is, guess what? You're going to have to do these sort of whiteboarding interviews as well. So there was the practical component. I really appreciated the emphasis on the job. And for me, it just became a roadmap of, hey, hopefully you can figure out how to get a job. That has to be the goal. But then you've got this confidence that you've learned something new and that you know how to learn. You learn how to learn. And then here's this roadmap that hopefully you spend more time digging into, which I still feel like I'm only at, that's why CS Primer has been really fun, where Oz really wants you to go deep into computer science versus a lot of people in the industry. When you're looking for new jobs, you're grinding on these sort of toy problem algorithmic websites just to get through it, but you're never actually like digging underneath. And we talked to all these people who are ex bootcamp grads who are doing interesting things. And the interesting things come from when you actually have, you allow yourself to explore and dig underneath. And yeah, so anyway, that's my experience. It was great, but I left it with luckily I left it with a hunger for more. And it certainly, I'm not upset that it didn't teach me everything.
Oh, you could hope for it.
Yeah.
It didn't kill your spirit.
Yeah.
Saying the bar high. But I think you should dig into boot camps a little bit to see, because I see a lot of overlaps with what you're trying to do in terms of like the peer-to-peer as a means for scale. Like, to give you a kind of sense, I don't know if Charlie, was your cohort like 20 or 30 people, because you were quite early.
Yeah, I mean, probably around that 30.
Yeah. So maybe a year or two later, the typical cohort size was 50 or 60. These folk were doing 10 to 12 week programs and getting employed as software engineers. Amazing. So it's like, don't do the 4 years, do the 12 weeks, start 100%. From whatever industry, history major, whatever. And at that time, things have changed a little bit. At that time, these boot camps were typically getting 90% or something of graduates into like high paid software engineer role. So kind of crazy success in terms of what they were aiming for. And it was basically peer-to-peer, like Charlie says. Even the instructors were like the previous, blind leading the blind, the previous years top graduates who would stay on. So like that aspect of it was very successful. There's also the school 42 that you may have encountered or heard of. Do you know have you heard of 42?
And having that right mix of the population mix is key, right? So it's not all blind and not all experts. And this is why, like, when I think of this, this experiential model, my brain just keeps going to like, I want 100,000 cohort, and I want it to feel intimate. And how do we achieve that? And one reason is because the bigger it gets, the more likely you can assemble these groups that have the right mix, right? Versus trying to plan small groups that I just kind of allergic to that. I didn't even want to try it. And that's why it was neat when we built our platform. There's so many constraints because you don't have time and money. We're like, how are we going to do the cohorting? And we're like, no time, no cohort. It'll just be, we'll just randomly show you people and add a follow button and we'll let it emerge. Like that alone went so far that we still haven't even we've messed with it a bit in terms of what's most interesting is the first thing I tried to do was tag users based on their quality of feedback, do it automated. So then when the algorithm's trying to surface, it checks how many I used to call them good note givers, have touched you, have commented on your work so far, to try to evenly blend the good feedback givers around. So my mind keeps going to like, what's the algorithmic way you could just do this at scale? But and why I said how will this work in other contexts is I tried to map out both like video game design, because that seems like a really fun one to do in this experiential model. Walk out with a prototype that you've gotten feedback on along the way, and it just comes down to you. Synchronous versus asynchronous is tough, and because I wanted to stay in this big global thing with lots of people, it couldn't be synchronous, so it had to be asynchronous feedback, which can be limiting. And it comes down to like, sending notes back and forth. But I mean, I haven't built this yet, but mapping it out, it seemed like if you get the right deliverables at the right size and the right mix of people, it can work in that domain as well. But there is something about live interaction that is important. And my design principle is always like, because you can get really confused when you're trying to design social systems around learning, and you can come back to saying, okay, why are we live again? Like, I just keep asking that question because it's not always obvious why we're live in many different cases, especially with story feedback. It didn't actually be so important. It wasn't actually so important. There's other cases where sometimes live's important, but the more I think about it, the less and less I can justify. Even when you're asking, in the case of like an expert doing a lecture in Q&A, someone can submit their question before and get the answer after. There's not a lot that needs to be live. I still question myself, what is the essential thing that has to be live? I still don't know. Is any live actually matter? I don't know. Because as soon as you have live, you have higher costs and more complexity to the system.
My If you want my quick view on that, it's that
Yeah, I'm
live
trying to
doesn't
learn
matter very
myself.
much at all, as long as there's a rapid feedback
Mm.
mechanism for the things that need rapid feedback.
Yeah.
So it's like, if you're, from the perspective of programming, if you're programming and you encounter an issue, and like, I've got a way for you to debug that, I've got like a worked solution or a hint or something, or you're just getting feedback from your development environment, then that's fine. You can do all of that asynchronously, because it's like kind of quasi-synchronous. You're getting synchronous feedback from an asynchronous source. Like, I've already anticipated the kind of issues that people might have. If it takes you a day to get unstuck on that, then that's not
That's too long. Yeah. And it makes me want to actually push ahead now, because you're teaching computer science. Computer science is changing. You could argue it's not changing at all or changing rapidly. I actually want to get your perspective. The tools are changing so fast that even when I was thinking through game design, because of what AI tools do, you're kind of like jumping back and forth between two realities. Reality one is the old reality, which is we're going to learn everything from the bottom up carefully, and it's all beautiful and interesting. Number two is we don't need to know. When I turn a light switch on, I don't need to know about what it goes on in that wall. I need the light to go on or off, and I'm going to move on from there, which is language is the new code. And I'm still always, I'm jumping back and forth all the time, and more trying to understand what this new world is and what do you teach in this new world.
Yeah. So
And
are
I'm
you
curious
wondering,
how
like,
deep you are in the deep learning thing. Like, I
yeah.
don't know if either of you are deep learning skeptics, fans. When did you get into neural networks, or have you always thought of them as like a little special thing on the side? It's like it used to be information theory. When I was into neural networks in Montreal, there was no textbook. I have the first one here now. I read it like 5 years ago at one school. It was too late.
Maybe this is just tell me if this is not the direction of the answer that you're looking for. But my belief is that this is another abstraction. Like, you don't want to think about how the light switch works, you just want to flip it and move on.
Mm-hmm.
I think that in software systems, abstractions leak a lot. We have some very successful abstractions that also can leak in very dramatic ways. Think of something like the Berkeley socket. It's like there is so much going on behind a network socket. It is so fantastic to be able to open up network protocols like a file, like have a TCP socket and just write to it as if it was a file. That enabled so much work where you didn't have to think about the light switch working. But it breaks in really dramatic ways. And I think that one of the main ways that my students get more interest and leverage and value in their work is by looking behind the abstraction and saying, I am the person who can debug this thing that typically works when it doesn't work. I think it's the same when you add neural networks as an abstraction, because they are not going to be perfect, and they're opaque in a way that some of our other abstractions aren't. Where like I can teach people to use Wireshark and capture the packets and directly observe what's going on in this behind the abstractions. I can teach them to trace system calls and to understand like the things that you took for granted. Here is the way that you like trace through this thing. With neural networks, that work is just starting, really. I mean, I'm not like across the interpretability literature, but like that's something that we really need to figure out. So I think it's like now we have another really powerful tool, like some would argue the most powerful tool, the tool to end other tools or something. Maybe it does replace other abstractions. But one thing to say is that people said that kind of thing about the compiler and they were right and missed the point at the same time. It's like compilers did change programming. It is very different to have a high level language rather than to write machine code. It's not a perfect abstraction. Some of us do need to go behind that. It does change the way people work, but it doesn't it doesn't have necessarily all the consequences that you expected. Like in the Fortran, like when Fortran came out, people were talking about Fortran eliminating programming.
But Oz,
Yeah.
with the compiler, you can go back and have a book like Nan to Tetris and go back, and eventually Nan to Tetris stops and says, beyond this is physics, and I'm going to stop there. But does, in the AI LLM world, like, will you ever be able to lift that hood up?
Right. That's a good one.
Or is it really just,
I mean,
like
Brit's lifting the hood up. Isn't that your work right now? Like, isn't that what you've been working on for a year? It's like, let's understand what's going on under the hood.
That's what I'm trying to do. And it's funny you say, because the Nan to Tetris, yeah, so you're getting there. And no matter what, you're going to hit this part when you dive into neural networks where you say, and then it's all magic. And then there's an output. And the magic, like it's either here or here, you hit this magic part. And it's funny when so I've tried to go pretty deep on reading like Anthropic's research and interpretability, and it's amazing if you go deep in the weeds there, which is like, yeah, we're at square zero, and they're like analyzing the tiniest little part of a part, like what, 2 attention heads limited to this very simple set of data, and they're like just trying to figure out what one little part does, and the rest is like all magic over here, but we're still trying to just take this tiny baby step. It's very interesting. And so yeah, that path there's actually, so I want to jump ahead to the end of, I'm actually finally have a first draft of the script today. Knowing I had to get on a call with you helped me try to finish it, but it's been a slog, and I'm trying to, where it ends is maybe just as interesting as even where it starts in the story. And so if I could try to encapsulate this, like, what's this magic part? What's most interesting is the godfathers of the field, which I'm happy to say are all in Canada, or came from Canada, are totally not in alignment now. And my favorite one is between Hinton and LeCun. And the argument basically now is, if it looks like thought, it is thought, or we're getting tricked, it looks like thought, but it's a trick. So LeCun says it just looks like it's thinking, it's not thinking. And Hinton says, well, if those thoughts lead to successful action, what's the difference? And we're back to philosophy. And so I think in the video, I'm trying to illuminate as much of that magic as possible, and it gets to in-context learning is really the, actually, maybe we could touch on one thing in the video, but the point is you end with this weird philosophical question, which I think is really neat.
Well, the goalposts keep moving, because didn't we have the Turing test, and now that's been blown away, and people are like, well, that was not really a good test anyway, and or like, Go is not really a good test or something like that. So we're just going to keep moving the goalposts. So
the goalposts moved all the way, and now we're saying, well, you either agree that, when we moved it that first time, it was a trick, and then we got tricked again, and we got tricked on the trick, and then the other side is saying that's a philosophical point. My point is the thing is working, and so you either agree with this first step or not. And that's what's really strange.
How are you presenting this? Or is this going to be another experiential, or is this Art of the Problem?
Sorry, this is Art of the Problem. It's taken longer because I've been busy. So Art of the Problem is like my pet baby. And so I can't wait. What's so fun about this video is that my normal process is to go back and read all the research. And what I found is that this story of making a neural network guess next token is old, and no one cared until 2 years ago. And even in the research community, they didn't care till 2017. Nobody cared, but it actually goes back to the 80s. And I read these papers by Ellman and Jordan in 86, and this is what I'm going to open with. And all the discoveries today are there. They were making 50 little neurons trying to predict sequential patterns, really simple sequential patterns, and then sometimes like 3-word sentences, tiny networks. And the first discoveries they made were all the same order, which is, it didn't work at first, but we kept training it, and then it started to work. That was the first one. And then we made it a little bigger, and it got better. And then we realized if we train it on different, and what he was writing at the time was Chomsky, and linguists at the time said, A neural network shouldn't ever work. It will never be able to understand language. And he actually references Chomsky in his paper that like, oh, there's certain, linguists are going to throw these complex sentences at us where the words are connected at a distance, and it's going to be too hard for these machines to do it. And I was actually going to pull up the sentence. It doesn't actually matter, but I like these examples. So in his this is again going back to the 80s, the early example he gave is handbrake car. I want to find this because it's good. The boy who married Chase. I sucked at grammar and I just hate it. So I like don't, these sentences annoy me. Boys who marry chases feed cats. These ones where it's like, you got to know which word's pointing to which word, and it's going to be difficult. And so he trained it on these harder sentences and it didn't work. But what was the solution? He started simple first. So he trained it on simple sentences, then the hard ones, and it got it right. He did it in phases of learning. Again, we're still back in the 80s. And he even said that he thought spatially that we know a concept, one way to view a neural network as a concept is like a position in a concept space. And he said these sequential patterns are pathways in concept space, which if you listen to Wolfram now, he's like drawing pathways of what an LLM is doing. People are just all seemingly rediscovering what was happening in the 80s, just in a really small form.
I like that we're back to the like James Burke's connection style of
right, because you have to go back because it's all there. There's actually nothing new in the big new models. I used to reject this idea of like, all they did was make it bigger. It's actually all they did, except the one breakthrough, which was the transformer.
Brit, one more selfish question from me because I know we're running out of time. And
I have one too.
Oh yeah, I got.
Okay. And then I've got a less selfish question as well. So selfishly for me, what I want to take from our conversation with you as someone who was inspired by something that is broadcast, like literally broadcast a TV show, went through that journey yourself, came to one of your big insights from Codecademy was that what the learner does is the key thing, but continues this like dual work of, on the one hand, build a platform for the learner to do things, and on the other, broadcast information in a particular way, like tell your own story in a particular way. How do you see your role as like a broadcast style educator in that context? Or how do you, another way of thinking of the same problem, I think, is how do you have, for X in a box, what is the role of the pro or the expert in that context of the peer-to-peer learning? Like, how do you reconcile these two very different styles of learning or styles of teaching?
Yeah, it's a good question because I do both. And so in this X in a box story experiential world, the pro is there for inspiration, period. Just inspiration, and inspiration and wisdom. And I think that goes a long way. My thing with, and this is back to the Codecademy experiments, maybe even the ones that weren't involving peer-to-peer anything, engagement is North Star. And you relearn this when you have kids. If you're not engaged, nothing matters. So it really is simple. It's just engagement. And of course, a pro will help you be engaged because they'll bring you inspiration. And in terms of role, I've actually, my kind of North Stars, I try to just, it's selfish, but not that, you just work on what's fun and then you'll have the steam to keep doing it. So when I think about Art of the Problem, it's me just heads down, trying to do something that interests me. And I don't actually think about, it only ever started with, I know that someone else will probably like this and it'll give them a good feeling to skip over the pain. And that's all it is to me, just doing that because it feels good.
Yeah, Oz, we talk about that a lot. It's like, what's the project that you're going to be thinking about when you go to bed or wake up and do? Maybe you should be working on that thing. And then on the pro side, one other thing I'd like to add, which I really appreciate in Oz's videos and overall style, is when the pro makes mistakes, show the students that the pro is not infallible. Oz, in your videos, you like maybe flub one or two commands and then you have to like figure out something unexpected that makes it feel real. I imagine that's not staged, that you are genuinely like, oh shit, something went
No,
wrong.
they're real mistakes.
Yeah, exactly. But then even you were talking about the community giving you input on what to teach next is also in it, like that you sort of feel like you're in a dialogue with the teacher and you ask questions, and I've seen you make videos that they've asked you to do, and that sort of makes me feel like the teacher is also one of us. So that was my reaction to those. My other question I've been thinking about for a while is, to what extent do both of you feel like you have to decalcify students when they come in, break their bad habits? That could be like, I'm not a math person type thing. Could also be my version of this failure mode for me is like, oh, once I have this iPad and that Apple Pencil, then I'm actually going to really like draw that comic. I need that device, and then that's going to solve my problem. Or maybe another like sort of decalcification is, oh, the story circle or the hero's journey, that's all you need. And I'm wondering to what extent like folks are coming in with like, oh, there's going to be one shining thing that's going to solve all my problems. Probably there is some technique or habit you have to teach. But yeah, does decalcification come into, I need to break students down and then rebuild them? Or you sort of feel like the curriculum itself is strong enough to get around any of that?
Well, I'm curious what you think, Oz.
I think it's hard in computer science in a way that it might be easier in other topics, particularly when something starts to get mathy, because there is a lot of like some people just develop hang-ups through school. I assume it's developed. Like I don't, just judging from the limited amount of work I've done with young kids, I think people come with an openness and like less self-talk. And some people have a school experience that excites them about tackling hard problems. And some people have a school experience that causes them to shut down when they encounter something that's challenging. So I don't know what the like distribution is, nature, nurture, whatever. But what I can say is that with adult students, I get a wide range of appetite for challenge, particularly when it comes to things that are mathy or like logic intensive. And sadly, I'm currently at the point where I need to just present my offering as a thing that is targeted at people who are at least somewhat further along the spectrum towards appetite for challenge versus those who are not. I'm not in a position where I feel like I can decalcify, as Charlie puts it, very effectively. Although I do try to, with things like not editing out my mistakes. Like there are small things I think that I can do to like build more of a culture of embracing the challenge. I've had students where this is a story I may have told on the podcast previously, like a very early day student when I was doing one-on-one teaching, just as we were trying to develop the curriculum, where we were not making much progress at all. And it was purely psychologically, because this individual was learning, but he was telling me that he wasn't. And trying to convince me and himself that he wasn't making progress and couldn't make progress. He was the kind of person who couldn't make progress. And that was a self-fulfilling prophecy. And we went down, like I spoke to his boot camp teachers, and we like really tried to interrogate this thing. And like I came to the conclusion that this was a very hard problem, and not the one that I was.
I'm trying to imagine if this was me. I don't think it was.
I mean, I'm just pointing that out as like this was a crystallizing experience for me, but everyone is on this spectrum. And like I really wonder where kids develop this, and like what early interventions could be. And like obviously I'm fascinated about the growth mindset stuff, although unfortunately the research on that is not good at all. I don't know if Brit, you've dug into it, but it's like, it'd be nice if that was.
We love telling ourselves stories about how humans work.
Yeah. So yeah, I don't know.
Dangerous.
That's my long story short, Brit. Like I just make it clear. I try and make it clear on CS Primer, like you are going to be challenged, and there to an extent, like I'm here to help you. Like I have solutions to the videos. I'm not going to give you a grade. You're not going to fail. Like,
Yeah.
I'm going to encourage you to face this problem. But if you see a bunch of problems and you see a system, like a learning platform that is structured around solving problems, and your first instinct is, no, I want answers, not questions, then you're going to go to another resource. Maybe in a similar way to like you're making YouTube videos, and you know that is partly just because you enjoy making the videos, and there will be an audience for that, even if it's like not strictly the one educational intervention that everybody needs. Like when you're saying you're at Codecademy, I'm not there to like fix all of education all at once. Yeah, like I'm presenting this as something that is for an audience. Sadly, like, it is heartbreaking to me that I can't like help everybody and decalcify. But I just simply don't have an answer.
You got to pick your battles. And so that's really, I like what you said. And the only thing I can add is I think you have to be so careful where the hurdles are. And I think the common thread in kind of anything I do is you want to avoid building calcium in the first place, just on the other side of that equation, which is you can't trigger people in any way. And by trigger, I mean use language, use overly complicated language on my Art of the Problem world. I'll never use a word that I don't know for sure you use. And it's so hard. I watch everything on like neural networks just right now for research, and people, there's no way an outsider could understand. There's so many words that words are just awful when they're incorrectly used. So I sand away every single word in a script. I make sure there's absolutely no way you don't know what that word means. And that takes a lot of work. If you do that, you get this nice ramp. And then just making a YouTube video is so different than a world of having a product where people are paying and pouring in. Like, that's crazy. It's scary. It's complicated. And so in that world, it's more about like, you got to shave every little edge off the user experience, because the triggers start at the login button, maybe not working, or the software you recommended had an update. You didn't put that in the instruction. Like, you cannot do enough to make it smooth, because then we're going to get to the hurdles you planned for, which is, oh, you're going to have, like you said, up front, you're going to have these conceptual hurdles, and you tell people up front, you want all that hurdle to be the hurdle that should be there. Often there's just so many hurdles that aren't related to the concepts you have to learn, whether in just a lecture or in a really annoying platform that might have, again, with my critique of Khan Academy, there were times where it's just too complicated. Just even employees themselves, we couldn't even use it because it changed so much. So I learned a lot there on, oh, you got to keep it simple.
Well, my last selfish question is, Oz knows that my nights and mornings project for a while has been, I've been working on this novel. It evolved out of National Novel Writing Month a couple of years back, ballooned into this 600-page thing. And
awesome.
I'm trying to pare it back into something good. I'm actually working with a writing tutor now who's like purely focused on story and backstory. So my final question is, I saw story experiential is for like age 13 plus, but is there an upper limit?
We have an adult cohort, which is 18 plus. And so, I'll send you a pass. I'd love to get your feedback on the product. And
amazing.
What I like about it is, it's for any story.
Okay, perfect.
And I just wanted to mention back, we should do another talk, because there's a lot to get into when you mentioned this thing about where do you teach people the low level fundamentals, going back to how a transistor works even before a transistor, and then going up that thing of abstractions. Which ones are we sure we want to teach, and when do we get off that bus, and when do we get on the deep learning bus? Because it's a different paradigm. And again, it starts from magic is at the bottom, and then, or you say, but below that, it's just matrix multiplications and then magic. It's still just saying it's all matrix multiplications is saying it's magic. And so where do we get on that bus? And what do new computer science students, where do they get on? And what does that delete over here? Because I just don't know. I don't think anyone knows that answer yet. And I think there's a lot in terms of going the other way. Or if we start at the high level, trying to understand neural networks is like an interesting alchemy of a little bit of brain science, a little bit of math, a lot of physics analogies. It's super interesting, and just like it's new waters to play in. So I'd love to go deeper on that sometime. And I don't know if that's not in your course yet. Probably. I don't know if I saw.
No, it's not. I'm gonna cop out and say I'm only gonna teach things that were invented in 1969. Not
There you
strictly,
go.
but like plus or minus a few years.
Yeah.
Because like there's just so much that everyone can still take from understanding. You know, when I say
Yeah.
1969, I'm talking about like the Unix and C derived everything, where it's like, you know, you've already been working in your domain, you're a web developer, whatever. Like, let's start to peel back the abstractions and see how this stuff works. That's how you get leverage. And so, again, to the point of like, it is a product for a market. I personally don't feel like I'm in a place to teach the machine learning aspects, whether like we're talking about LLMs or more traditional machine learning techniques. But there's always going to be stuff. I mean, if we spoke to Greg Brockman or someone, if we took someone from OpenAI and asked them about their day-to-day work and like how they fix a bug, and like it's still the traditional system stuff. And
It's a little bit of both, right? It's the traditional system stuff and this new thing that we don't have enough experts or understanding about. Right. My favorite example is this in context learning was something people weren't even sure was going to happen. And then it was actually a research surprise at saying, think step by step, dramatically improve performance. So that's what I mean by the person who had the idea to say it's think step by step didn't need to know how a transistor worked. And I'm an electronics geek. I made my boys do circuits and it's all great. But honestly, I'm not always sure how far I need to go, where I want to make sure that they would understand why saying think step by step is something that researchers might not have even thought of and was a surprise. So, and then that's just one in the last year of all these weird ideas that seem simple and obvious that are, it's like, it's so fruitful. And that's just why clearly I'm excited about it, because nobody knows what's going on exactly. It's really neat.
And I felt
like I
this
said, the
same.
Godfathers are saying it's all fake, or it actually doesn't matter and you're just talking philosophy. It's so cool the time we're in.
Well, I want an answer to this because I feel like every time I try to unravel the hood, I feel like I have to go back to Codecademy and do pre-algebra. And it's like, okay, just give me a couple weeks and I'm going to work my way back up. And then I fall off the train. I'm one of the folks who didn't complete the MOOC. So
yeah, I feel I got lost in old ML research where even when I started the series, I was going to be teaching methods that are already obsolete, like long short-term memory recurrent neural networks. Like it's this weird, what I realize is that's one of many weird human engineering hacks that got replaced by let the machine learn. You either understand that the network will learn and get the hell out of the way, which Tesla, I'm shocked they just recently learned this. Like they're doing next event prediction on a path. But for so long, they were only using neural networks to identify things in a scene. It still had hand-coded thing going on in the path planning. They finally let that go. And you just see that across the field of all this human engineering just getting all absorbed and replaced by one method. It's so easy to dive into the wrong waters with machine learning too, which is why I'm trying to do a thread where, okay, just stay on this thread because it's actually 99% of the picture.
I got to run, gang, but I feel like Oz's last message in a previous episode was, don't let a GPT take all the fun. You know, those are words to live by, I think.
But Brit, if you can do the hard work of understanding the core of how we understand, the meta understanding of LLMs, etc., then that's going to be really important work. So
I'm going to try. I don't know. We'll see. Thank you.
Amazing. Great chatting. Looking forward to the next one. See ya.
Yeah, it was really fun.
Yeah. Bye.
Take care.
Bye.